Okay, so we want to find out when the cannonball hits the ground. When the cannonball comes down and hits the ground, that would be the same thing as when the height is 0 here. So height is 0. This is the equation we're looking to solve. It's the same as the roots. When I look at this equation and I'm looking for t, I see an exponent. There's multiplication here, and there's addition here. And so when I think about reversing the PEMDAS order to pull off the layers to get to t, I need to take off the addition first, take off the multiplication second, and then take off the exponent. And taking off a square means square rooting. So, first thing to come off is the addition with subtraction. So take off subtract 150 from both sides. That's negative 150 is equal to negative 16t squared, because this is now gone. Second layer, so that was step 1. Second layer to pull off is the multiplication, which is by negative 16. So I'm going to divide by negative 16, do the opposite. So that'll cancel this out, leaving me with t squared over here. And I'll pull out my calculator. And I would normally use Desmos or something like that, but just because for the video's sake it's easier. So this comes out to be 9.375. It is positive because a negative divided by a negative is positive. All right. And then at this point I need to square root. So technically I'm square rooting both sides. That's what undoes this and makes this a just t. And so then I need to square root that side. So when I square root that, get the trusty calculator out here, whoops. And I square root that number that I have right there. I get 3, so this is what the calculator tells me. I get 3.06186 blah 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 blah. Okay? So I think it's probably fair to say t is about 3.1. I do know that this parabola does come down over here and hit over here at time negative 3.1, but that doesn't make any sense. Time can't be negative, not when we're talking about an object dropping. So the only possible answer, even though there's 2 positive and negative, for this problem, we would say at 3.1 seconds, because this is a real world problem.